Hello again. This is Roger Koch Barr for the Bioelectricity course. This is week 6, a wonderful week. So this week we get to work on propagation. Now, propagation is a wonderful topic because, first of all, it reflects our main interest in bioelectricity, that things propagate from one place to another, so it's not just an action potential starting in your brain, it's an action potential flowing down from there to your toe to tell it to do something. It's not just an action potential starting in your toe, it's an action potential propagating back up to your brain to say that, yes, I've done it. It's the event that we care about, what makes your brain think, your heart contract. All those special things are propagation. Propagation is complicated because it is the composite of all these things we've talked about before. These are all coming together into propagation. You'll enjoy this week. Generally, the way this week is organized is in the first part of the week. The concern is with observing propagation. So first, it's just a matter of looking at propagation, and mainly we'll look at some interesting things. So I wrote observe beside that. A little bit messy, but that's what it's supposed to say. And then in the second part of the week is more analytical. More a matter of looking at what is happening and saying, now that we see it, what do we make out of it? So now let's move on. In this Lecture 2 sequence, we'd like to talk first, just as a starting point, about subthreshold stimulation. We will use this experimental setup throughout today's work, so I'd take just a moment to talk to you about it. In this experimental setup, for our numerical experiments, there's a single cylindrical fiber, and it's laid out here along the x-axis in that fashion. Along our fiber are arrayed several electrodes. There are 2 stimulus electrodes. The first stimulus electrode is over here. Stimulus electrode R, you notice it's down towards the left-hand end of the picture. Second stimulus electrode S is over here towards the right. Then there are 2 measuring electrodes. These measuring electrodes will show us graphs of what is happening at these 2 sites. Site A, which is over here to the left, and site J, which is in the middle. So sites I and J, show us what is happening at the left-hand end and in the middle of our fiber. We'd expect something that starts at one end to propagate to the middle, because generally that's what action potentials do, but let's just check and see. Please notice on this slide that the stimulus electrodes here and here are not the same as the measurement electrodes. One of the measurement electrodes, the one on the left, measurement electrode I, is at the same place as stimulus electrode R. But the other measurement electrode, J, is out in the middle of the fiber where there is no stimulus electrode. That gets to be a significant point later on. So now the question that we're going to ask in various forms for the next few slides is the following question. If one stimulates at electrode R, stimulates here, do you see a response here at I And then, do you see a response here at J? Let's just look and see. So now on this slide, what is present is at the top a smaller version of the stimulus fiber diagram. In the middle is a trace showing the stimulus waveform. So if we look at the stimulus waveform, we see, this is similar to what we have used before in that there is a pulse, a current pulse. Current is injected across the membrane at site R, and at site R, that current has a magnitude of 0.04 microamperes, or in other words, 40 nanoamperes. Now, what does the fiber do in response to receiving that stimulus? That is the question. And we see the answer. It makes a little blip at voltage electrode I, which is plotted in the red trace. So at the voltage electrode I, we have this little blip shown in the red. It comes up and then it fades away. We've seen these before as subthreshold responses. At measurement electrode J, we'd say what happens here is nothing. We just don't see a thing at J. So the conclusion here, just looking at what's there on the face of it, is that a small stimulus, it makes a little blip at R. That is to say, underneath R should be I, and nothing at all at J. In this sequence of slides, I thought I'd show you some pictures of the Eno River. The Eno River at the Eno River State Park, which is close to the Duke campus here in North Carolina. Thank you for watching. We'll be back in a moment.